Hey everyone, continuing with our transformations, we're looking at the combination, basically performing not just one particular transformation, but more than one. All right, so this will be a easy start to combinations because you'll be learning a bit more transformations, and then finally we look at combination of all the techniques you have learned thus far. So right now we just do something that's relatively simple. All right, so let's say we again with the original graph or original equation as gy equals to hx, and let's say you want to transform the graph to gy equals to, keep it simple, let's just look at the changes to x's, let's say 2x plus 3. All right, so as you can see, we need to do two things. Scaling, because we now have 2x, and then we have plus k or minus k. So in this case, we have plus 3, so which means we need to do translation. All right, so what is the order? All right, now I'm here to tell you that you can do either translation first, then scaling, or scaling first, then translation. However, one of those orders will not allow you to use the numbers 2 and 3, while the other will allow you to use 2 and 3. All right, so let's explore which one is quote unquote better, allows you to use 2 and 3 directly. All right, and we start with, let's say we do scaling then transformation. So in this case, we have scaling and then transformation. All right, so we scale first, scale parallel to x-axis with scale factor 2. Just kidding. Half. All right, don't forget your scale factor is 1 over k. So in this case, it is half because now you just need half of your x value to get the same. All right, so what happens is this. We had gy equals to hx. Now it becomes, after our first transformation, gy equals to h2x. All right, if we want to obtain 2x plus 3, if you remember that everything we do applies to the x, which means is we will then have from gy equals to h2x to gy equals to h bracket 2 bracket x plus k. Remember, our translation affects the x, and therefore x plus k. You notice that our translation is affected by the scaling factor as well, which means we cannot translate by 3 units. Instead, we must translate by 3 over 2 units. All right, so translate 3 over 2 units. Since it's plus, we will get the negative x direction in negative x direction. All right, not negative x-axis, but negative x direction. This will then give us gy equals to h2 bracket x plus 3 over 2, which will then give us 2x plus 3. All right, so that is if we were to scale first and then translate, which brings me to my next point, that it is often better to translate first then scale. Why is that so? All right, so let me draw a line through. So if we were to translate first, we're gonna get, I'm gonna skip all the things. So now we're gonna translate by 3 units first. So translate 3 units, again, since it's positive, negative x direction. All right, I'm just keeping it short form. We then had gy equals to hx becoming gy equals to h bracket x plus 3. All right, now if you notice, whatever we do affects the x. If we were to scale x now, we will not be touching the constant because we're only applying the scale factor to the variable x, not the plus 3. As such, it is often better to translate first and then scale, whether is it on the x variable or the y variable. All right, of course, If we were to talk about y equals to fx, and then it'll be a different story. All right, so we had the second step. Now we scale hx plus 3 will now only affect x only, so you'll get h kx plus 3. We do not affect the plus 3, therefore we get gy equals to h kx plus 3. So in this case it is 2x plus 3. Don't forget, Q factor is 1 over k, therefore 1 over half is 2. Alright, so there we have it, the combination for our x only of scaling first or translation first. This is an important skill. In the next video I'll look at the translation, the combination of y equals to fx, and see what we can do to them as well.